Yeah, so a bit of an introduction about myself. Hi there, this is Kuljot Singh Bakshi, undergrad student at IIT Bombay at the Department of Environmental Science and Engineering. I'm also a Udemy instructor with two courses under my belt. One is Azure Generative plus Predictive AI 10 plus hours, which includes all the concepts related to Azure OpenAI, be it function calling, retrieval augmented generation, vector indexing, and stuff like that. And the second one is AI Builder with Power Apps Unleashing Efficiency. I'm also a certified Azure AI engineer and a most valuable professional at C Sharp Corner, on which I write blogs very frequently. Please feel free to connect with me on LinkedIn as well. Let's get started with the video without further ado. This video is going to be an introduction about the concept of Azure ML vector indexing, which you can club with your Azure OpenAI resource as well. So the main reason behind the creation of this video was the main question or the most vital question that I get from a lot of people when I discuss about Azure OpenAI is they talk about using their own data. What if they want to you know, put in some PDF documents, unstructured data, and then use their chat engine on top of that unstructured data, and then let the chat engine retrieve data from that unstructured data. What if they want to achieve this functionality? Well, this video is an answer for exactly that question. And to solve this problem, we have something called as Azure Machine Learning Vector Indexing, which uses your embedding model of Azure OpenAI, which is namely the ADA engine, and any of your chat engine in your that is deployed in your Azure OpenAI resource. So let's get started with this. So coming to the question, what is vector indexing when speaking fundamentally? So vector indexing is nothing but the process of storing your data in the form of coordinates associated with the Euclidean space. So it is for all the engineers out there, it is nothing but defining your data in terms of vectors, in terms of I, J, K uh, vectors, and basically deals with the Euclidean space that you have defined in terms of mathematics. Vector search after vector indexing provides enhanced semantic search with the help of algorithms such as approximate nearest neighbors. So now, I want all of you to focus on this word and this terminology, which reads out something as semantic search. So before vector indexing, what did we used to do? So we used to take in our data, take in our query from the user, and then exactly match that query with the data that we had on our hands. But now with vector search, what vector search essentially does is it takes in that query from the user and tries to derive a semantic meaning. That means the words with of the query of the user might not be matching exactly to the words that are stored in your data. But what it does it takes in that meaning of the query and tries to correlate with that meaning of the query with the data that is already stored on your database. So this is what is something known as semantic search. So semantic search is an enhanced version of some searching or querying your database by not exactly matching the words, but by matching the meaning of the query that is input by the user and then searching your database, going through your database based on the meaning of the query that is input by the user with the help of some algorithms such as proximate nearest neighbors. So what happens is in vector search and vector indexing is first of all you generate vectors for your data you with the help of any vector embedding engine. In our case, it will be Azure OpenAI's text embedding engine, which is called as the ADA version, if I'm not mistaken. Then with the help of your embedding engine, you generate vectors and then you do vector indexing on your database. You store that vector database in any storage of your choice, and then you take in an input query from the user You run searches, you run semantic search based on that query on your vector database, and then what all what all searches you get from the semantic search, those searches are are displayed to the user with the help of your chat engine in the front end. So this is a diagram which I thought of to make you understand what exactly is vector indexing uh, in more simpler terms. I get it, vector indexing can be a little bit of a difficult concept to grasp at first, but tried my level best with this diagram to let you understand what exactly is vector indexing. So on this diagram, I have a Euclidean space with my y-axis right over here and the x-axis right over here. All right. So I have three images. One is of a shirt, one is of a pant, and one is of a skirt. So the shirt is placed in the Euclidean space with a coordinate of 1 comma 1 because, and it is more towards the positive x-axis and more towards the positive y-axis, because the positive x-axis represents the color red and the positive y-axis represents the category of shirt. Hence this coordinate 1 comma 1 is justified for this red t-shirt. On the other hand, I have a blue pant with the coordinates of -1 comma -1, obviously because the negative x-axis represents the blue color and the negative y-axis represents the category related to pants, and hence -1 comma -1 is the generated coordinate for my blue pant. Now speaking of the green skirt, or where should the green skirt be placed? So first of all, think of green skirt. Green skirt is essentially an item that is worn on your lower body. So it must be related somewhere to, the category of pants. Hence, it is placed closer to this blue pant right here. And speaking of the color green, if you have noticed in the color spectrum, the color green is moreover related or closely placed towards the color blue. Hence, this based on the color schema of the skirt, which is green, it is also placed closer to the negative x-axis. Hence, the coordinate -0.8 comma -0.8 are justified for this green skirt. So essentially, this is what is happening for vector indexing. So you take in your data, store that data, and you take in an embedding engine, you take in a vector embedding engine and generate vectors for all of these data. So in my case, my data over here is a red t-shirt, blue pant, and a green skirt. So on a large scale, this is exactly what is happening at the very grassroots level. Okay, so speaking of vector indexing algorithms, we have four main vector indexing algorithms. One is the flat indexing. So flat indexing is the simplest vector indexing algorithm. It is an algorithm which offers very high accuracy, but on the other hand, you uh, run into the disadvantage of, because it is a very time consuming algorithm as compared to the other three algorithms. So the second algorithm is inverted vector indexing, IVF algorithm. It is a speedy algorithm. And what happens in a inverted vector indexing algorithm, you take in your data, you generate vector embeddings for that data, and based on the vector embeddings for your data, you divide your data into specific clusters. And then for each cluster, you find the coordinate of the centroid of that cluster in the Euclidean space. And then when a user inputs a query, you generate a vector embedding for that user query. And then you try to find, using semantic search or any uh, similarity search such as cosine similarity, you find the closest centroid in the Euclidean space for that user query, and then based on that specific cluster, you run semantic searches for finding a specific result for your user query. The third is locality sensitive hashing algorithm. It is again a speedy algorithm as compared to flat indexing and inverted vector indexing. And what happens in locality sensitive hashing? All similar vectors are hashed into the same bucket, and your user query is first of all converted into a vector, and then through hashing it is compared with all the vectors. First of all, a bucket is found based on your user query, and then searches are made against your user query in the same bucket against all the vectors. So essentially you are targeting on a smaller area with the help of locality sensitive hashing, and hence the speed increases because you're not exactly making searches or exactly uh, comparing your user query against all other vectors that are not included in the hash bucket that you just selected. The fourth and the most complex, and I think the most advanced vector indexing algorithm is hierarchical navigable small world algorithm. It is the most efficient, most complex, and multi-layered approach to vector indexing. So speaking of Azure machine learning vector indexing, you have two ways to go about it. First of all, it is through the face index. So face, FAISS, pardon me if I'm not pronouncing it right. So sorry for that, but this stands for Facebook AI Similarity Search Library. So it is an open search library, and you can use this pathway of using Azure machine learning vector indexing for development and testing purposes. And we are going to be using exactly this uh, open source library that in our labs following this video. And yeah, so face indexing is locally stored with no high cost, so hence you can use this particular pathway for development and testing purposes again. The second pathway to go about Azure machine learning vector indexing is Azure AI search indexing. It is good for it is suited for production level, and it takes a lead in through this face index pathway in a way that it has enhanced scaling and security and enterprise level, and it also supports hybrid information retrieval. So what this hybrid information retrieval means is uh, you can have, with the help of Azure AI search indexing, you can have your vector components and the non-vector components stored in the same storage. But with the pathway of face index, you can only have your vector components stored in the storage. So yeah, this hybrid information retrieval is not supported by this face index path. For more insights into the world of Azure OpenAI, quickly navigate to udemy.com and enroll in this course as quickly as possible. The course is titled Azure Generative OpenAI plus Predictive AI 10 plus hours, in which you'll get concepts such as Master Azure OpenAI and key concepts such as function calling, text embedding, RAG, GitHub Copilot, and more. We have exclusive content focused on topics such as Azure OpenAI, retrieval augmented generation, predictive AI, AI 102 for short, and vector indexing, and much more cool stuff like that. So what are you waiting for? Enroll now.